free body diagrams are, on the one hand, they look rather simple, but they can get complicated. And when you get into bigger problems, more complex problems, they're really actually very handy. I'm going to talk you through the worksheet that you looked at this week. The bottom line about free body diagrams, so hopefully you've read the worksheet. If you haven't read it, go read the worksheet first, then come back and watch the video. A free body diagram, or one of these pictures, kind of like what I've shown with the rocket ship. We could draw the object, or we could just draw a dot. In this case, since I found it online, I grabbed the rocket ship. The arrows tell you the size of the forces. So this first one, it's got an up arrow that's rather big and a down arrow that's smaller. That tells us when we look at it that the up force is larger than the down force. That means since the up force is bigger, there's an overall net force that is upwards. That tells us that it's going to accelerate upwards. If we switch it up, a different scenario, if the two arrows are exactly the same, that means the net force is zero. There is no unbalance. Two forces cancel each other out. Since there's no unbalance, that means the rocket's not accelerating. This could mean the rocket's in the air. Maybe, well, if it's in the air, this down force, whether it's in the air or not, would be gravity. And then whatever the up force is, maybe it's the rocket's motor or thrust or something, whatever word you want to call it. Maybe it's in the air and moving at a constant speed. Or maybe it's on the ground. If it's on the ground, then it wouldn't be the thrust of the rocket, it would just be the ground pushing up on it. We're going to talk about that more next week. The ground pushing up on it matching gravity. Either way, it's not accelerating. Maybe it's on the ground and not moving, or maybe it's in the air, in the air and not accelerating. If we wanted to do a free body diagram of a rocket that was accelerating downward, it's got to have a downward force. That's probably gravity. Either there is no upward force, or if there is an upward force, it's got to be smaller than the downward force. We need the downward force has to be bigger. That communicates that it's accelerating down. Switching it up a little bit, if we consider something that's got four forces, forward, backward, and up and down, like a car on the ground, if all the forces cancel out, kind of like this one, the left and the right cancel out, the up and the down cancel out, overall we've got no net force. That means the car's not accelerating. If we bump it up a little bit, if the forward force is bigger, then it's going to be accelerating forward. Or I typed it to the right. One for you to try, if I just tell you that it's skidding to a stop. Okay, first of all, we can't get away from gravity, so there's going to be a downward force. Since the question doesn't say anything about it falling through the ground, there's got to be an up force. Since the question doesn't say anything about it like trampolining into the sky, I know that that up force and the down force have to be the same. Now this little hint in here, the rule of the road is when you apply the brake, you take your foot off the gas. So if it's skidding to a stop, there's no more forward force because you've taken your foot off the gas. There's only a backward force. That's what I would expect for a car that's skidding to a stop. Elevator questions. Hopefully you've looked at it, but if we just eyeball it, the upward force is greater. So it's accelerating upward and the net force is upward. Okay, the last question here, this one's always goofed up. Oh, by the way, on elevators, I didn't show any left-right forces because usually an elevator is just up and down. This one's always goofed up. Let's say we've got a person standing in an elevator. Gravity is going to be pulling them down, so I got a down arrow. It says they're moving upward, but the most important thing is it says they're moving upward at a constant speed. If they're moving upward at a constant speed, that means the up arrow has to be the exact same as the down arrow. If the up arrow were bigger, that would mean it's accelerating up. If the up arrow were smaller, that would mean it's accelerating down. Since it says it's going at a constant speed, it doesn't matter whether it's moving up or down. All that it matters is that the constant speed means that the two forces have to be equal. That last one is the one that's most commonly goofed up. People think that since it's moving up, the upward force has to be bigger. At some point, the upward force had to be bigger to get it moving up, but once it's moving up at a constant speed, those two forces are exactly the same size. You've got a worksheet to look at, you've got answers for those, and if you haven't got to it yet, reading over the sheet, listening to this video should make the turn-in question hopefully doable. The turn-in question is a little bit more complicated. because I gave you numbers. So you have to do a little bit of math, a little bit of addition or subtraction to figure out what the net force is. I'm going to leave it to you to see if you can figure it out. As always, email if you have any questions.